At first light, Devil's Tower does not look like a mountain. It looks interrupted. The base spreads outward like a buried flare. The walls rise in thousands of long vertical lines, too regular to feel accidental and too massive to feel natural in the ordinary sense of the word. Around it lies a broken apron of stone, as if fragments once peeled away and fell where they stood. Seen from a distance, it resembles a trunk cut flat at the top and left to harden in place. Seen from the air, it becomes stranger. The surrounding land appears stripped back, levelled, exposed, while the tower remains like the surviving core of something no longer there. So what exactly are we looking at? The accepted explanation is familiar. Devil's Tower is described as an igneous intrusion, or the hardened throat of ancient volcanic activity, only later exposed as softer surrounding rock eroded away. The vertical columns are said to be cooling fractures, a common geological pattern known as columnar jointing. Over immense spans of time, wind, water, frost and gravity removed the enclosing layers and left the resistant core standing alone. In that account, the shape is unusual but not mysterious. The timing is deep. The mechanism is simple. The tower is not a stump, not a monument, not a ruin. It is just rock behaving as rock behaves under heat, pressure and erosion. And yet the official explanation, while coherent, leaves a residue behind. Not a contradiction in the narrow scientific sense, but an unease. Because the eye does not merely see a tall rock, it sees a form that appears cut, fibrous, rooted out and isolated in a way that seems almost designed to trigger comparison with once living structure. The same discomfort returns at other sites: flat-top mesas, detached buttes, columns standing like splintered grain, landscapes that look less built than sheared. The question is not whether geology can name these shapes. It can. The question is whether naming them has also ended the investigation too early. What changed was the explanation. The hidden theory begins there. Not as a rant and not as a demand to discard geology, but as a serious, if highly unconventional possibility. It suggests that some formations now classified as volcanic remnants, erosional towers, basaltic columns or isolated mesas may be the mineralized remains of biological structures from a much older Earth, one whose atmospheric pressure, chemistry, electrical environment and life scale may have differed profoundly from our own. In its most extreme form, the theory imagines a world forest of almost incomprehensible height, with organisms reaching miles into the sky. 40 miles is the provocative number. Whether that number is defensible is another matter. But beneath the exaggeration lies a narrower claim worth examining: that the planet may preserve the stumps, root fields and buried biomass of a former arboreal world, and that we have mistaken at least some of those remains for ordinary stone. Start with physical geometry. Devil's Tower rises more than 800 feet above its immediate surroundings, but what matters is not just height, it is the relationship between the shaft, the base and the debris. The columns are vertical, packed, parallel and often hexagonal. I'm giving the entire mass a bundled appearance, almost like fibres compressed into stone. At the foot of the tower sits a tireless field of fallen columns, many long and prismatic. As though the outer skin has been spalling off in strips, the top is relatively flat. The lower margin flares. The surrounding plane feels denuded. Geology says this is exactly what cooling rock and selective erosion should produce. The alternative view says the geometry is too suggestive to ignore. A central core, an outer rind, collapse around the perimeter, and a plane that reads less like untouched terrain than like stripped substrate. No single resemblance proves anything, but what remains after dismissal is still a resemblance of unusual force. Then there is the matter of landscape pattern. When isolated towers are viewed on the ground, they can be explained one by one. When viewed on maps, another impression emerges. Around many buttes, mesas and resistant outcrops, drainage lines branch outward in dendritic spreads that look, at least visually, like root systems exposed after surrounding cover has been removed. Satellite views of certain desert plateaus show circular or oval central masses ringed by fractured escarpments and radial wash channels, as if erosion has excavated around a harder centre and revealed the subsurface architecture. Again, geomorphology has terms for all of this. It speaks of uplift, differential weathering, caprock, jointing, runoff, and badland incision. But the pattern repeats in a way that keeps inviting the same forbidden comparison: core, flare, spread, exposure. While the record shows a planet full of detached vertical masses standing in landscapes that look less built up than cut down. Material evidence makes the theory harder to dismiss entirely because Earth unquestionably preserves the remains of trees as stone. Petrified forests are real. Silicified wood exists on every continent. Entire trunks have been mineralized so completely that cellular structure can survive in detail while the organic tissue is gone. Coal beds, lignite seams, amber deposits, peat basins, and carbon-rich strata testify to a world that once buried vegetation on continental scales. The stone remembers. Mainstream geology interprets these as the products of ordinary ancient forests, swamps, sedimentation, and time. That interpretation is powerful and often sufficient. But hidden history investigators notice something else. Civilization already accepts that organic forms can become rock, that forests can become seams, that wood can become mineral, and that entire ecosystems can be compressed, transported, buried, and reclassified until their original geometry is almost unrecognizable. If the planet can turn trunks into quartz and forests into fuel, the distance between biology and geology is not absolute, it is procedural. This is where a fair objection must be admitted. By current biology, a 40-mile-high tree is impossible. Water transport in xylem faces severe limits. Structural loading rises brutally with scale. Wind stress, material strength, gravity, metabolism, and atmospheric composition impose boundaries that modern trees do not approach. Even the tallest known trees, magnificent as they are, remain tiny beside the numbers claimed by the most enthusiastic versions of this theory. Geology, for its part, does explain columnar jointing, volcanic necks, plateau dissection, and erosional remnants with no need for vanished superflora. Those explanations are not invented to suppress alternatives. They are grounded in repeatable processes and measurable outcomes. And yet they do not fully settle the matter. They explain how certain stones fracture. They do not explain why the same family of forms so often presents itself to human perception as severed organic mass, or why the boundary between petrified wood and ordinary rock becomes conceptually rigid only after the classification is made. The official explanation answers the mechanism. It does not always exhaust the image. If that were only a problem of one tower, it would mean nothing, but the pattern does not disappear. Across the American West, isolated buttes stand on flatter country like truncated columns. In Monument Valley, in the mesas of Arizona and New Mexico, in the laccolithic and volcanic remnants of the Southwest, the eye keeps encountering vertical masses with flat or domed tops, separated from the surrounding plateau, as though the land between them had been stripped away. Shiprock rises from the desert as a central spine with radiating walls, almost like a splintered root collar frozen in stone. In other parts of the world, there are basaltic provinces where columns cluster in bundles, stump-like masses project from plains, and table mountains sit on widened bases above scarred ground. No serious investigator should claim that all of these are one thing. They are not. Some are volcanic, some are sedimentary, some are erosional accidents, but what matters is recurrence. The same visual grammar appears again and again: truncation, bundling, flaring, isolation, exposed substrate. The pattern repeats. The archives complicate the story further. 19th century survey reports, mining descriptions, railroad notes, and early natural histories often use language that sounds embarrassingly literal to modern ears. Surveyors described petrified trunks, forest beds, fossil wood in place, coal measures of extraordinary thickness, upright trees through multiple strata, and silicified masses resembling timber. Early photographers posed people on gigantic sequoia stumps, as if the stump itself were the monument. Our logging museums preserved cross-sections large enough to count centuries, as if time could be displayed as furniture. The public became familiar with enormous wood. Then the categories hardened. A standing mineral trunk became paleobotany. A carbon seam became energy. A columnar tower became volcanology. A mesa became geomorphology. Each object went to its own institution, its own vocabulary, its own budget line. What had once invited a single question was redistributed into separate answers. The record is still there. What changed was the filing system. That bureaucratic separation matters more than it seems. Many hidden structures in history are not concealed by dramatic conspiracies. They are dispersed by administration. When evidence is divided among agencies, disciplines, and legal definitions, no one is assigned to ask whether the pieces belong to the same original process. A petrified log is studied as a fossil. Coal is regulated as a mineral resource. Amber is catalogued as resin. Basalt columns are mapped as igneous fracture. Mesa surfaces are analysed as erosional remnants. Insurance, land use law, mining rights, and academic departments all depend on these distinctions. Once the categories settle, curiosity narrows. A question that crosses them begins to sound unserious before it is ever tested. Economics then deepens the inertia. Entire industries extract the buried remains of ancient biomass without needing or wanting a wider interpretation of what that biomass once was. Bureaucracy does not need to suppress a theory if accepted categories already make it invisible. Consider timing. The modern industrial world expanded by burning the compressed residue of ancient life. Coal and oil powered the railways, furnaces, ships, and grids that allowed nations to map and excavate the planet with unprecedented speed. At almost the same moment that geology was formalizing its categories, industrial states were consuming vast buried carbon deposits on a scale no earlier civilization could have imagined. It was an age of extraction and explanation running in parallel. One branch of knowledge measured seams, strata, and fuel value. Another branch built deep time narratives to account for them. Those narratives were often correct, but they were also convenient. They converted the remains of former worlds into resources and then into abstractions. Lignite became a reserve estimate. Bitumen became a production figure. Fossil forests became museum exhibits. The possibility that buried carbon, silicified trunks, isolated towers, and stripped terrains might belong to a larger morphological pattern was never prohibited. It was simply uneconomic. No agency existed to investigate the Earth as a possible field of erased arboreal megastructures. The question fell between departments. At this point, the obvious objection returns with force. Where are the roots, the branches, the leaves, the soils, the transition layers that a real planetary forest of impossible scale should have left behind? It is the strongest challenge, and it deserves more than a hand wave. The hidden theory answers by pointing to destruction, burial, and replacement. It imagines a world-level catastrophe or long-duration environmental shift that ground, burned, flooded, mineralized, and then reworked the original biomass until only the most resistant basal structures remained recognizable. What would branches become after pressure, heat, dissolution, and millions of years of chemical exchange? What would leaves look like after transport and compression across continental basins? Perhaps coal, perhaps shale, perhaps nothing identifiable at all. That answer is speculative, but so is the assumption that present-day categories capture every stage of deep transformation. When landscapes are erased, survival is selective. What remains is not a full organism, it is a residue. Even myth and naming, treated carefully, add an uneasy layer. Cultures across the world preserved images of world trees, axis pillars, sky-supporting trunks, sacred poles, and mountains treated as once-living vertical beings. Such stories do not prove geology. They should not be used that way. But they do preserve a strange continuity of perception. People looked at certain forms and saw not merely hills, but uprights, shafts, trunks, pillars, linking levels of the world. Indigenous traditions around Devil's Tower do not call it a fossil stump in the modern fringe sense, but they do mark it as a place where ordinary categories fail, where stone carries memory and verticality, has meaning beyond scenery. That does not certify the theory. It does remind us that rational classification is not the only historical response to unusual landforms. Long before formal geology, people knew that some objects resist ordinary explanation. And this is the point where the theory becomes less about giant trees and more about epistemology. 40 miles may be the wrong number. But tree may even be the wrong word if the original organisms belong to forms unlike anything now alive. But the deeper claim is that Earth's surface may preserve fossilized architectures so large and so altered that modern disciplines no longer recognize them as once biological. A stump is only a metaphor until it is measured, sectioned, compared, and tested. But a metaphor can still point toward a blind spot. The danger is not that the theory sounds strange. The danger is that strangeness itself has become a reason not to look. Once an object is labelled mountain, plug, neck, mesa, butte, or columnar basalt, the investigation often stops exactly where it should begin, at morphology, material continuity, and pattern repetition across scale. Seen that way, the unsettling possibility is not that the Earth once held fairy tale forests towering into space. It is that the planet may contain remnants of biological histories whose scale and form no longer fit the categories we inherited. There is something almost procedural in the way these questions vanish. A tower is mapped, a seam is mined, a petrified log is displayed. Anomalous resemblance is dismissed as pareidolia. Institutional confidence closes over the gap. The stone remains where it was, the records remain where they were, the pattern does not disappear, only the permission to connect it does. Look again at the tower. Look at the isolated buttes, the flared bases, the stripped planes, the bundled columns, the carbon seams, the petrified trunks, the amber, the upright fossil trees, crossing layers. The desert mesas standing like amputated cores. Perhaps all of it is ordinary geology seen through an undisciplined imagination. Perhaps, but perhaps the imagination has only noticed a pattern that official language trained itself not to see. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.